Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're going to continue our discussion with radicals, and we're going to be looking specifically at multiplying binomials with radicals. I have a couple examples on the board, but what I want to tell you is that all of these principles are starting to combine, and there is a specific purpose to why we're doing multiplication of binomials with radicals. Basically, what we're going to do in this video and where we're going to leave off in this video is setting us up to ultimately do rationalizing denominators with radicals, which I'm going to cover in the next video. You're also going to see here how this ties into some of the special products of binomials that we discussed in previous videos. If you want to follow along with what we're looking at here in written form, you can see that on page 68 of my book, Algebra in Words, which is on Amazon, and the link to that is in the description box below. So anyway, let's get started. I have 3 examples on the board. Now, this is actually not that complicated, and most of this will not be that new to you. In short, we're going to be applying the FOIL method, because these are 2 binomials multiplied together. Without further ado, let's just start. So in the first example, we have 2 square root of x plus 1 times the binomial square root of x plus 4. And we're going to apply the product rule. So let's do the product of the first terms. 2 square root of x times square root of x. Now, when we're multiplying radicals, it's important that you compartmentalize the coefficients and the radicals and kind of do them sort of separately. Coefficients is like 2 times the unwritten coefficient 1. 2 times 1 is 2. But in terms of the radicals, where we have square root of x times square root of x, these. Okay, and I'm just going to write that here for now. Square root of x times square root of x is square root of x squared, right? And what do you remember about when the root and the power are the same? It equals the base. So in short, the square root of x times the square root of x equals x. That goes here, and you're going to be seeing a lot more of that going forward. So remember, whenever you have a square root multiplied times itself, it equals the base. So that's product of the first. Now let's do the product of the outside. 2 square root of x times 4, and we're going to be multiplying the 2 times the 4, which is 8. And since there's a radical attached, we just attach that, square root of x. Now we'll do product of the inside. 1 times square root of x is square root of x. And finally, the product of the last, 1 times 4 is 4. But now let's look and see if we have any like terms. Well, we have 2x, and there's no other like terms with that, so we'll leave that as 2x. But what about the middle terms? And if you remember from the last video, these are like radicals, so they're like terms. They are both square root of x. So we can add and subtract them by their coefficients. 8 plus the unwritten coefficient 1, which is going to make 9 square root of x. And then we have 4, and there's no other like terms with that, so we're just going to write plus 4. So that example is done where we multiplied those 2 binomials with radicals. So now let's look at the next one. And let's look at this closely. Let's just read it first. It's the quantity 6 plus square root of 3 times the quantity 6 minus square root of 3. And do you notice anything about that? Hopefully you do notice from previous videos that this is a special case. These are conjugate binomials. The first terms are the same, the last terms are the same, and the middle signs between them are opposite. So you could do the traditional FOIL method, but you'll notice that the product of the outer and the inner terms cancel out to 0, meaning you can apply the shortcut method. And the shortcut method means you can just multiply the product of the first. 6 times 6 is 36. And the product of the last. The square root of 3 times negative the square root of 3. And what is the square root of 3 times square root of 3? It's 3. And since it's a positive times a negative, it's going to be negative 3. But now in this, unlike other conjugate binomials that had variables, these now simplify down to like terms, just numbers. So now we can do 36 minus 3, which is 33. And again, you're going to be seeing more problems like that. This is setting you up to doing rationalizing the denominators, which I'll say a little about at the end, but then we'll see more in the next video. And finally, let's look at the last example. The square root of 2x plus the square root of 3y times the quantity square root of 2x minus the radical 3y. So what do we notice about this problem before we start? Well, what we notice is, unlike the previous examples, there's radicals in both terms, in both quantities. Also, like the previous example, they're conjugate binomials. So we can just shortcut to the shortcut rule, meaning just multiplying the product of the first. The square root of 2x times the square root of 2x is 2x. And the square root of 3y times the square root of 3y is negative 3y. And that problem's done. There's nothing left to do. The 2x and the 3y are not like terms. So long story short, there's nothing more to do. Now before we end the video, I mentioned that multiplying binomials, specifically conjugate binomials with radicals, is setting you up to do rationalizing the denominator, and that's what you're going to do and see in the next video. How that applies is that when you have a radical as a binomial in a denominator, you need to multiply something times the top and bottom of that fraction to get rid of the radical in the denominator. And you do that by multiplying by its conjugate. So anyway, I'm going to cover that in the next video. Thanks for watching, and see you in the next video.